In this video, we will practice some more triangle congruence proofs. So we are given that AC is congruent to AR. So of course the reason is going to be given, but it's very important that we mark these in the picture. So segment AC is congruent to segment AR. Next, we are given that angle 1 is congruent to angle 2. So the reason, of course, will again be given, but let's mark those. So angle 1 is congruent to angle 2. Well, guys, that's it for the given. So it's time to look for something that we can mark automatically. The two things we can mark automatically are shared sides and vertical angles. I see vertical angles right here. So we can just mark those automatically. And the statement is going to be that the one angle is congruent to the other angle. A common mistake is to say angle A is congruent to angle A. We cannot do that. These are two different angles. You can't call them the same thing. So we need to use the three-letter name instead. So we will say angle CAT is congruent to angle RAD. For the reason, we will say vertical angles are congruent. All right, whenever you have vertical angles, you write them down and say vertical angles are congruent. That is enough information for us to say that the two triangles are congruent. Let's put those letters in the right order. So we have triangle CAT. I'm going to make this the yellow triangle. So here's triangle CAT right here. And now we have to set up the white triangle. So the yellow angle C corresponds with white angle R. So R goes first. Yellow angle A corresponds with white angle A. So that just leaves angle D. So that finishes off the congruent statement. We still need the reason. We're talking about something like side, 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 side angle, side, that type of thing. And I see that we have two angles and a side. This is going to be angle, side, angle. It was either going to be angle, side, angle, or maybe it was going to be angle, angle, side. Both of these involve two angles and a side. The difference is if the side is between the two angles, that's when it will be angle, side, angle. And I see that here's one angle and here's the other angle. And so the marked side is right here between those two angles. That's what made it angle, side, angle. So we've now proven that the triangles are congruent. Sometimes that's the end of the proof. It all depends on what we are being asked to prove. If this had said prove that triangle CAT was congruent to triangle RAD, we would just stop and we would not need the last row. But notice we've already proven that the triangles are congruent, yet there is one more thing that we still have to do. We have to prove that angle 3 is congruent to angle 4. Well, when you've already proven that the triangles are congruent and you want to go ahead and say that an additional pair of corresponding parts are congruent, the reason will always be CPCTC. Looking back at our work from a previous video, CPCTC stands for corresponding parts of congruent triangles are congruent. Problem number 2. This one is completely blank, so we really have to do this proof all by ourselves. We might as well start with the given. We are given that segment UV is congruent to segment SU. So let's write that down. Segment UV is congruent to segment SU. And of course, the reason will be given. When the given is a congruence statement, that's all there is to it. You just move on to the next given. The next given is not a congruent statement. We're going to write it down, but you should already be thinking about how we can turn this into a congruence statement. But first, let's write down angle SUT and angle VUT are right angles. All right, that is not a congruent statement. When they give you something that is not a congruent statement, the very next line you write needs to be a congruent statement. Well, first let's go ahead and say given. And we can mark this in the picture. In fact, I forgot to mark that segment UV is congruent to segment SU. And now let's mark that angle SUT is a right angle, and so is angle VUT. So how can I turn this into a congruence statement? Well, I can simply say that angle SUT is congruent to angle VUT. That makes sense because all right angles are congruent. And in fact, that's the reason. We can just say right angles are congruent. And we can abbreviate like that. So guys, that's it for the given. We only had two given. One was a congruent statement. The other one was not a congruent statement, so it took 2 lines because we had to turn it into a congruent statement. But now we're completely finished with the given. But we still don't have enough information to prove that the left triangle is congruent to the right triangle. So it's time to look for something that we can mark automatically. The two things we can mark automatically are vertical angles or a shared side. Vertical angles or a shared side. So for this problem, we see a shared side right here. That's side TU. So we can go ahead and say segment TU is congruent to segment TU. Whenever you say that something is congruent to itself, the reason will be the reflexive property. Memorize this. Now that's enough information to prove that the triangles are congruent. So let's go ahead and say the triangle on the left, which is SUT, triangle SUT is congruent to triangle VUT. The reason, will it be side, 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 side angle, side, or what? Well, this will be side, angle, side. I see that we have 2 sides and the angle in the middle. So that's side, angle, side. So we have proven that the 2 triangles are congruent. If that is what we were asked to prove, then we would be done and I wouldn't need this last row. However, we weren't asked to prove simply that the triangles are congruent. We are being asked to prove that angle S is congruent to angle, well, what will that be? Angle S corresponds with angle V. So the only thing we could possibly prove is that angle S is congruent to angle V. So whenever you have already proven that the triangles are congruent, and then you have an extra pair of corresponding parts that you want to prove congruent, the reason will be CPCTC, because corresponding parts of congruent triangles are congruent. Let's do a couple more. All right, here's another proof that's completely blank. We can handle this. Let's start with the given. We are given that segment AB is parallel to segment DE. All right, so that is given. Notice that this is not a congruence statement. When the given is not a congruent statement, before you do anything else, you need to take that given and turn it into a congruence statement. So parallel lines can be turned into congruent angles. Parallel lines will lead us to congruent angles. Maybe I'll just say this off to the side. Here are two ways that parallel lines will lead to congruent angles. So here's a pair of parallel lines, and here is another pair of parallel lines. It's all about the transversal. The transversal is the line that cuts across like this. If you have parallel lines cut by a transversal, if it forms a Z shape or an N shape, then the corners are congruent. And the reason will be alternate interior angles are congruent, because these are alternate interior angles. On the other hand, if the transversal cuts across like this and makes an F shape, see the sideways F? Then the corners of the F are congruent, but these are corresponding. You know what? I should have said alternate interior angles theorem. Let me change that. We say alternate interior angles theorem. So these are corresponding angles when it forms an F. And we will say the corresponding angles theorem. Or you could say postulate. So let's see which one it is. So whenever you see parallel lines in the given, you're going to end up with two congruent angles. And it's either going to be alternate interior angles if it's a Z or an N, or it will be corresponding angles if it's an F. So what I recommend is tracing the lines that are parallel. So AB is right here. So here's AB. Let's just trace it. And DE is right here. Let's trace it. So these are the lines that are parallel. We have our choice of transversals. So we can either cut across this way or this way. I don't think it's going to end up mattering which one we choose. So let's just pick one. So let's say if we do this way. There's my transversal. So the corners of this Z will be congruent. So for example, we can say angle BAC, so angle BAC is congruent to angle DEC. DEC. Now the reason, because this is a Z shape, these are alternate interior angles. So the reason will be alternate interior angles theorem. Okay, if you did this problem by yourself, if you're one of my students and you already did this problem, then you might have done the transversal the other way, and maybe you wrote that these angles are congruent. So if you have angle ABC is congruent to angle EDC, that is also correct. All right, well, let's go back to this. We also know that C is the midpoint of BD. So that's another given, so let's write it down. Notice I didn't just write the two givens in a row. Because the first given was not a congruent statement, I took an extra row to make a congruent statement out of it. So then I move on to the next given. So C is the midpoint of segment BD. So that's given. Again, this is not a congruent statement. So the very next thing I'm going to do is turn this into a congruent statement as fast as I possibly can. Well, it says C is the midpoint of segment BD. So I really need you to focus on the BD. In fact, here is segment BD right here. If C is the midpoint of that, that means that segment BC is congruent to segment CD. So segment BC is congruent to segment CD. Now, what's the reason going to be? When you're looking for a reason that goes here, often there will be a clue in the previous statement. So if you look diagonally at the previous statement, look for the key word. Notice that the key word is midpoint. That is a good clue that the reason will be definition of midpoint. Some students get very confused between definition of midpoint and definition of segment bisector. But it's all about keywords. If you look at this reason and the previous statement, if the statement says midpoint, then it's going to be definition of midpoint. If the statement mentions bisector, then it's going to be a definition of bisector. All right? If it's a segment, it'll be segment bisector. If it's an angle here, it will be definition of angle bisector. Okay, so now we have used up the given. They gave us two things that were given. Neither one of these were congruent statements, so we turned each one into a congruent statement. But now we have truly used up the given. Whenever you use up the given, it's time to look and see if there is anything that you can mark automatically. And one more time, the two things that we can mark automatically are vertical angles, which are like this, or shared sides, which usually look something like this. In this problem, we have vertical angles. So it's time to mark those. We have vertical angles right here. So the statement will be that the left angle is congruent to the right angle. Be careful, do not say angle C is congruent to angle C. These are not the same angle. You cannot simply call them both angle C. We need to use the three-letter name. So we will say angle ACB is congruent to angle ECD. And the reason will be vertical angles are congruent. All right, that's why we marked them, because they were vertical angles. So vertical angles are congruent. Now we have enough information to prove that the triangles are congruent. As soon as you see that you have the three pieces of information congruent, you want to go right on ahead and say that the first triangle is congruent to the second triangle. So let's go triangle ABC is congruent to triangle. Let's be careful. On the left here, we started with A. So we had yellow angle A, and that's corresponding with white angle E. So we need to start off with E. And then we went to yellow angle B, which is blank. So that's going to correspond with white angle D. And that leaves only angle C left. The reason will be angle, angle, side. Whoops. I see that we have two angles and a side. So it was either going to be angle, angle, side, or it was going to be angle, side, angle. The difference is it can only be angle, side, angle if the side is between the two angles. Well, I'm noticing that one angle is here, the other angle is here. The angle that is marked is not between these two angles. So because the side is not between the two angles, that's how you know it is angle, angle, side. So look, we have now proven that the triangles are congruent. In the past, we would be finished right now. However, it all depends on what we are being asked to prove. In this case, we were not being asked to simply prove that the triangles are congruent. We started with that, but we are being asked to prove an extra thing. we are being asked to prove that specifically segment AB is congruent to segment DE. When you have already proven that the triangles are congruent and you are asked to show that an additional pair of corresponding parts are congruent, the reason is CPCTC. Corresponding parts of congruent triangles are congruent. Here's the last problem. It should be a little bit extra easy because some of these statements and reasons are filled in for us. So we often will start with the given. We are given that segment PM is parallel to segment ON. So the reason, of course, will be given. But we notice that this is not a congruence statement. This is a statement of parallel. We need to turn this into a congruence statement. We have learned that parallel lines will lead to congruent angles. So we are going to turn these parallel lines into congruent angles. And we're going to do that by tracing these parallel lines. So give me a moment because I want to use my highlighter this time. Okay, PM is right here. ON is right here. So those are the two lines that are parallel. Now look for the transversal that cuts across between them. So here is the transversal. Hopefully you can see the N shape that is formed by the parallel lines and the transversal. Whenever you have that, the corners of the N are going to be congruent, and these are alternate interior angles. So be careful to use the three-letter name. So the first corner here, where the O is, we will call it NOM. So angle NOM is congruent to angle. Now this lower angle here at M, three-letter name, PMO. PMO. And because these are corners of a Z, these are, or an N, these are alternate interior angles. So that's why the reason was alternate interior angles theorem. Okay, great. So that's the first given, and we turned it into a congruent statement. Now here's the second given. MN is parallel to PO. So of course we will go ahead and write given. But once again, we need to take this statement of parallel and turn it into a statement of congruence. So it's going to be the exact same thing. We just have different parallel lines. So this time I'm going to trace MN. Okay, hold on. Let me grab my highlighter once again. So here is MN and PO. And it looks like it's going to be the same transversal as before. Okay, so you can see that Z shape. The corners of this Z will be congruent. So this time we are talking about this corner and this corner. So those angles are going to be congruent. So that is angle POM and angle NMO. So, whoops, I forgot the angle symbol. And it's the exact same reason, the alternate interior angles theorem. So that takes care of both givens. So we are all out of givens. So that means we need to look for something that we can mark automatically. The two things that we can mark automatically are vertical angles or shared sides. Vertical angles or shared sides. In this picture, we have a shared side. So we can go ahead and mark this shared side. And this is side OM. So in the proof, we will write segment OM is congruent to segment OM. Whenever you write that something is congruent to itself, the reason is the reflexive property. And guess what? That's enough information to prove that the two triangles are congruent. I see the three pieces of information. As soon as you have enough information, go ahead and say that the two triangles are congruent. So the first triangle over here, I'll make this the yellow triangle. Okay, so this is triangle MNO. And this will be congruent to triangle. Well, we're starting off with angle M. The yellow angle M corresponds with the white angle O. See how the yellow angle M has the double mark? On the white triangle, that's the letter O. So we're going to start off with the white angle O. Next, we have the N. So on the yellow triangle, the N is blank. So on the white triangle, that's angle P. And then finally, they end with the letter O. But the yellow angle O has a single mark. On the white triangle, the single mark is on M. That's why we'll finish up with the M. So triangle MNO is congruent to triangle OPM. The reason will be angle, side, angle. I noticed that we have two angles and one side. So it was either going to be angle, angle, side, or it was going to be angle, side, angle. It will be angle, side, angle if the side is between the two angles. And I'm noticing if you look at the yellow triangle, here's one angle, here's the other angle, and here is the marked side. Notice how they all line up. The marked side is between the two angles. That makes this angle, side angle. Are we finished? No. If we had been asked to prove that the triangles are congruent, then we would be finished. But we were asked to prove something extra. We were asked to prove that segment PM is congruent to segment ON. Whenever you have already proven that the triangles are congruent, and then you have to prove that an extra pair of corresponding parts are congruent, the reason will be CPCTC. Corresponding parts of congruent triangles are congruent.